Alrighty. Thank you everybody for joining us. As we have people filtering into our webinar, I'm just gonna go over some housekeeping rules, general things to chat about. So thanks so much for being here tonight, everybody. My name's Morgan. I'm an AmeriCorps member with Conservation Nebraska's Common Ground program. Our mission at Conservation Nebraska is to protect our state's natural legacy by educating the public, supporting communities, and increasing civic engagement, which we accomplish through locally led education efforts and community engagement projects to address local conservation concerns such as tonight. Before I introduce our speaker tonight, I do have a few things to go over. Our audience here on Zoom, your cameras will be turned off and you will be muted throughout our presentation. Any questions you do have, though, please go ahead and put those in the Q&A section, and we will address those as we go or at the end if they are held until the end of the presentation. We also will launch a poll at the end. It's a very brief survey following the presentation. It shouldn't take you longer than 1 or 2 minutes to complete. And this survey really does help us support our programs like this one. So we do appreciate everybody taking the time to fill that out. And tonight we have our speaker, Moriah Brown. Welcome back. Thank you so much for being here with us this evening. And a little bit about Moriah, excuse me. She is a PhD student in civil engineering at the University of Nebraska, where her research focuses on the occurrence and behavior of microplastics, antibiotics, and antibiotic-resistant bacteria and genes in agriculturally dominated watersheds, excuse me. Originally, Moriah is from Knoxville, Tennessee, where she earned her BS in civil engineering from Howard University in 2022 and her MS in civil engineering with a specialization in environmental engineering from the University of Nebraska in 2004. And with that, I will hand it over to our speaker tonight. Thank you very much.
Yeah, thank you guys. So I'll go ahead and share my screen. All right, can everyone see the screen all right?
Yep, we can see it.
All right, so I'll be talking about microplastics in an agriculturally dominated watershed today. First, I'm gonna just talk about the lab that I work in at the University of Nebraska. So we are the Environmental Quality and Communities Lab. We mostly focus on investigating the fate and effects of emerging contaminants, specifically in agro ecosystems. Um, like Morgan mentioned, from my bio, I mostly work on microplastics and pharmaceuticals in water in an agriculturally dominated watershed. Since I'll be talking about microplastics today, I first want to talk about what microplastics are. So microplastics are any plastic particle less than 5 millimeters in size. They could be either primary plastics, which those are manufactured already at that small size range, or they can be secondary plastics, which are plastics that are broken down from larger plastics until they reach that size of 5 millimeters or less. And the image on the right just kind of shows the different sources where microplastics can come from. And there's a lot of sources of microplastics. They basically can come from anything. We mostly, of course, find them where there's human activity. Um, so generally, just because we use so much plastic in our world, they basically do come from almost anything. So my specific project that I work on is watershed monitoring of Shell Creek to determine the spatial and seasonal variations in microplastic concentrations of an agriculturally dominated watershed. And why is this important? Microplastics are a pollutant of growing concern, and they are increasingly being found in terrestrial freshwater settings as well as marine settings. But we know less about their concentrations in agriculturally dominated watersheds. And the objective of my research is to investigate the variations of the spatial and seasonal concentrations of an agriculturally dominated watershed. And the images at the bottom show examples of microplastics we have found in the past. So the left two show examples of what we like to call fibers, kind of like stringy materials, kind of just looks like something like a piece of lint off of clothing, really, is what it looks like. And the two images on, or the three images to the right, show examples of what we like to call fragments. And they are usually found to look like just almost perfectly round beads. For our study area, I was working in the Shell Creek watershed. It's an agriculturally dominated watershed in east central Nebraska. It includes about 2,500 farms, the over 1.3 million head of cattle, swine, and poultry. And we had four sampling locations along Shell Creek. So the furthest upstream would be our Newman Grove location. And we had Lindsay. We had a site near Columbus. And our last final site was called USGS. It has a USGS gauge site at that site. And the land use and within the watershed is mostly cropland with about 76%. And again, it is mostly corn and soybean grown in that area. So before I get into the results, we had two different types of samples that we were collecting. I won't get too much, I won't really go over at all the methods. Um, didn't want to get too technical with that, but we were collecting surface grab samples, what we call them, or just we were just grabbing water at the surface of the stream. And then we were also collecting sediment samples, which was just grabbing the soil or sediment along the banks of the stream. So first, for our average microplastic concentration, we usually are looking for a trend moving from upstream to downstream. In the past, we have been able to see trends, especially if there was a wastewater treatment plant nearby, because usually those are also a source of microplastics. So we'd usually see like an increase just downstream of the treatment plant. But here at the site, we did not have any treatment plant input. So there was no real trend moving throughout the watershed. And our average concentration range from 9 to 14 microplastics per liter at each site. And this concentration isn't necessarily high or less necessarily low compared to others. It's kind of just right in the middle. But if you're comparing from this agriculturally dominant site to an urban site, the concentration would be a whole lot less because generally in the urban areas, you're going to have more human input, and that just again will equal more sources of that plastic pollution. So from what I was mentioning about the fibers and the fragments from the images I showed earlier, um, we were finding mostly fibers in our water samples here. About 95% or more of our sample contained fibers. Um, and that average concentration of fibers at each location was between 1.8 to 2.7 microplastics per liter, while the average concentration of fragments was less than 1 microplastic per liter. So pretty small amount of fragments compared to the fibers that we found here in this location. And for the seasonal variation, we did observe a possible seasonal variation. So especially with the fall months here, but spring also had a slightly higher concentration than the summer months. Um, and we think this may be due because of the increase of human activity, especially in the fall with crop harvesting and the different land application of fertilizers. So usually, again, the more human activity you have in the area, usually you're going to have more plastic pollution. And this size distribution, so part of our methods is we are kind of separating the plastics into different sizes. To do that, we're just pouring the water sample through 5 different size sieves, and those sieves are at size 63, 125, 250, 500, and 2,000 micrometers. And we do this because looking at the different sizes could help us possibly determine potential sources or even just how long that piece of plastic has been in the environment. But overall, our size distribution was pretty evenly distributed across the different sites. So the first image at the left is the percentage, so it's pretty even across. And then the second image to the right is actually the actual concentration that we are finding. And even when we separated this out into the different seasons, spring, summer, and fall, um, again, it was fairly evenly distributed, just a slightly higher percentage of microplastics in that 250 size category for the spring. Now for our sediment samples, the results of those. So again, looking at that microplastic concentration, again, with our sediment samples, we did not find really a trend moving across the watershed. Our US, our yeah, our final site at the end of the watershed had the highest concentration, but overall not too much of a trend because these values are pretty close together in range. And that range was from 2 to 3.3 microplastics per gram instead of liter this time. And again, we were finding more fibers in our sediment as well than we were finding fragments. Slightly lower with just above 65% instead of that overwhelming 95%, but still more fibers than we were having fragments. And the average concentration of the fibers this time was from 1.4 to 2.6 microplastics per gram. And again, the concentration of fragments was less than 1 microplastics per gram. And for the seasonal variation, it did not have the same variation as we did for our water samples. And this time we actually had the highest concentration in the summer months. Um, this could be because it takes longer for the plastic to actually settle into the sediment that we're probably sampling. So it could be kind of like a time lag effect that we're seeing, as in we might have seen the higher concentrations in the fall or spring for our water samples, but then we won't see that same kind of effect until later as time goes on and the plastics actually have time to settle into the sediment. And instead of a size distribution, we use a different method for the sediments. We actually have three different density solutions we use to extract the microplastics from the sediment samples. And those solutions are just water. Then we have a salt solution and a zinc bromide solution. Zinc bromide is the densest solution, and in that case, that also gave us the higher percentage or the highest percentage of microplastics found across each site. Um, and that's just because the denser the solution, you're going to end up with more particles that are less dense in that solution that we are able to extract. And in conclusion, just comparing our two different samples here for water and sediment, both of them did not really have a trend throughout the watershed when it came to the average concentration. And for the microplastics, again, the average concentration was 9 to 14 microplastic per liter, while for the sediment, it was 2 to 3.3 microplastics per gram. And for both of the water and sediment samples, we had mostly fibers found. Um, and also, we had a difference in the seasonal variations between the two. While the water samples had higher spring and fall concentrations, and then the sediment samples just had the highest concentration in the summer months. And for the water samples, the sizes of the microplastics are evenly distributed across the sites and the seasons, while for the sediment samples, the zinc bromide solution, which was again the densest solution, had the highest percentage of microplastics found. Great. That is all for my presentation. Would gladly be able to answer any questions.
So, Mariah, with your research, I guess, and kind of what you guys are finding out, and what is, do you find that people are understanding of like why this is a concern and why we need to be aware of this? Or, I mean, are people responsive to what's being done with this research and the issues that this can cause?
I think the more we talk about it, yes, because I think the big issue with the microplastics is um, we do not um, know the human health impacts of them yet. So we do know that they can um, have other contaminants absorbed to like the surface of the microplastics that may cause human health issues. But the plastics themselves, we don't know too much about how that affects human health. And that's, I think, the big important part of the research um, is finding out how much does this truly impact our human health with us being exposed to so much of the microplastic pollution. And I think there was a question in the chat as well. Yeah. But the difference between, yeah, fibers and fragments are um, just mostly what they look like. So the fibers kind of look like material that would come off of your clothing, stringy, almost like a piece of lint. And fragments are going to be more bead-like, kind of your harder plastic material looking.
We do have a few people just saying thank you. You know, this is really important work. So, much appreciated. So I know like your primary focus is in the watersheds, but are there other areas or I mean, is there more to this than just what's happening in the water, or is there groups focusing on that, or is this just primarily where you're finding this pollution at?
I think the main concern for everyone has, and the main focus for everyone doing research in microplastics has been water, whether it's marine or yeah, freshwater systems that I work in. But plastic is also in the air as well. These particles are small enough where they are able to float around in the air. I have not really seen much studies on that, and that is also something a challenge for our research as well. Sometimes with contamination in our samples is we don't know if it truly sometimes truly came from the water after during processing. It could have been just another like outside contamination while we're actually processing the samples in the air. Because again, it's kind of like if you just think of it, sometimes the plastic is just kind of like a dust particle. If you think about it like that, just kind of floating around. You know how dust kind of floats around in the air sometimes too.
Yeah. All right. Um, I do not see any other questions at this time, but if any of our attendees did have any questions, maybe they think of something later, would there be an email address that you're comfortable sharing, or is there somewhere they can go to like ask you some follow-up questions if that's needed?
Yeah, I can share my email in the chat as well. Or you can, I guess if you have outlets to share it, I do not mind sharing or having you, Morgan, share my email.
Okay. Yeah, I will follow up with attendees, and that's perfect. We do have another question. It says, will these areas be sampled again for comparison?
So we're actually done sampling. The data that I shared today was actually just from our first year sampling. We in 2023. So we also sampled in 2024. So we'll be able to compare the 2024 and 2023 samples together. Also for our future work, we still need to do some more further analysis to figure out confirm what we've counted as plastic in our samples as actual plastic. So that's something that else needs to be done. And this further analysis will also help us determine what type of plastic um, that could be in our samples. And then knowing that helps us kind of understand the possible sources that these microplastics are coming from. Because again, it is kind of hard to determine actual sources, especially in communities, because you would think that there shouldn't really be any because there's not a lot of human activity, but because we still have farmers, actual land management practices going on in those areas, that there is a little bit of pollution going on. Just figuring out where it's coming from is the next step.
Perfect. Um, well, I don't see any more questions for now. Um, but I will go ahead and follow up with our attendees at the end too. And our presentation will be posted to Conservation Nebraska's YouTube page too. So if anybody missed anything, they will have the opportunity to go back and see that. And I do appreciate everyone taking their time tonight to be here with us. Moriah, thank you for giving us your time. And I hope everyone has a great evening.